So this is Burke Egner, and he's a STEM teacher at Southwest Middle School in Albert Lea, and he is going to teach us about cross-curricular coding with Chrome. You can call it 4C or you can call it C4, whichever one you would like. And I am going to put a couple things in the chat for you to, I think all the materials you have are going to be there. So you will need access to that. They're going to need access to this to get going on the coding tonight even, right, Burke?
Yeah, and they should all have access. So it should be public view.
Okay.
They can share that with anybody, right? So if they want to give it to their friends, colleagues, I'm going to leave it. I just leave it up. And as long as I'm employed with the Albert Lea School District, it's there. So make copies of what you want, put it into your own drive, but share and share freely.
That sounds good. Go. So I'll turn it over to you.
All right. Well, my name is Burke Egner. I'm a teacher up at Southwest Middle School. I'm going to start sharing our screen. We're going to kind of kick off with a little bit about me, about our presentation, just kind of what we are going to do here today. Let me get into this. So here is what we're talking about today. So this is 4C cross-curricular coding with Chrome. A little bit about me. I'm a Google certified trainer, Microsoft certified educator. Really where I got into the Python was Raspberry Pi. I actually went out, and if you really are interested in Python and get into this, I truly recommend getting a Raspberry Pi certification. They have grants. I went out to California, did it in San Francisco. Great time, a lot of great people, great network. If it's something you want to learn more about, I can run you into the right directions for that. PLTW certified for automation robotics, magic of electrons. I'm also our district technology integration coach for our school district, helping teachers plan and integrate technology and curriculum district-wide, running the gamut K-12. And so I do that kind of in my spare time, if you will. Sixth grade technology elective teacher at Southwest Middle School. Little history, I started in 2017. We didn't really have a digital citizenship program or did any technology program. So created a digital citizenship class, 3D design modeling class, got some PLTW certifications to do magic of electrons, automation, robotics, and then came up with and teach a coding and video game design class, trying to get those things done. I was the 2019 STEM Educator of the Year for the Southeast Service Cooperative in 2019. And I've been in education for about 17 years, kind of been all over, started in Arizona, moved to Texas. I've been in Minnesota now for 7 years. And so trying to kind of get in here. So we're talking about why Python. Why do we want to start with Python? You guys have block coding, you've got Java, you've got HTML, you've got all these different languages. Really, it's, you know, and wherever you start, as long as you're getting them into the coding, it's good stuff to get them into. But I'm going to give you why I think Python is the place to start. The first thing is there's this a group called TIOBE, and TIOBE ranks programming languages based on their popularity, what kind of jobs are out there, what kind of support there is, user communities. So they look at what are the most popular programming languages, really designed to help college students look at, if I'm going to go get a job in coding, where should I be? What are people looking for? What are people doing? What are people talking about? And so right now, Python is number 3. It's been in the top 5 really for the last 5-6 years. And so it continues to grow in popularity. There's all kinds of great things that you can do with Python. And so this is, as of March 2021, it's number 3 of all programming languages. And so that really helps. It's a popular language. Employers need it. Kids love it. People want it. It's a high level language. And what that means is it's very close to our natural language. You can get into some programming languages, and if you have any experience with programming, you can get into where you're coding ones and zeros into binary, and it gets very far from our natural spoken English. Python is a high level programming language. So we use terms like print to display stuff on the screen and things of that nature. So it's not too far off, and it's a great way if you're teaching language arts skills to get kids into coding. And we'll talk about and show you guys some of the things that we can do with it. Next thing we've got is Python enforces what are known as white space rules. And this makes for clean code. And I'll show you examples of where it is. It can be very problematic or a pain at the start when you're learning how to code Python, but it makes so that you've got very clean code. This is, if you're a language arts teacher, making sure that you're indenting and you're putting your tabs and your spaces in there. Python makes it so that you have to use indentations. You can't have extra spaces. Everything has to be clean, neat, and tidy. It can be very problematic when you're trying to debug or look at problems with your code. But once you get it and you start coding and putting your code into nice, clean, formatted sections, it makes it really neat. There are some languages that best practice is to have clean code with everything organized in little boxes or areas or tabbed over, like you're making an outline or something like that. But some programming languages don't require, like if you get into Ruby, you can code just line after line after line and not have any spaces and still make a very valid working code. But it's impossible for anybody else to really see or know what you're doing if you got code all over the place. So Python is great because it teaches you to code clean. And the last thing is going back to that rated 3 on the TOB index is there's tremendous community support. None of this stuff that I'm going to show you today is my own. I didn't invent any of it. I didn't come up with any of it. Other teachers have put into databases. They've learned about it. They've talked about it. I've gotten the code from other people, shared it. Great organizations, great communities, and we'll kind of point you to some directions that you can get towards the end if you're looking to get some support. And so there's a lot of stuff out there about Python that we can get into. When we get into this, we got to start with some terms, just so you guys know what we're talking about. First thing we're talking about is the sequence. Coding is very sequential in nature. And this can be very beneficial to you. You have to put stuff in order, and we're going to find out, and you'll see as we're getting into and start doing our coding, everything works line by line. So if I want something to happen that is counting on something above it, I have to make sure that I've got it and I've created everything because it happens in an order of steps. We have to make sure we know what those steps are. Code is the language that tells our computer what to do. A function is a set of built-in actions that the computer can perform or user-defined actions. And we're going to create some of our own functions tonight. We're going to use some predefined functions. We're going to really get into it and start getting some coding going. And a variable. A variable for our terms is something that stores a value at a named location. And this you can have a lot of fun with, and kids often have a lot of fun with it. But then I'm going to talk to you about how we got to reel them in and make sure their variables make sense. And so how we're going to get those and make those happen. Keep going on. We talk about an argument. An argument is a value that's going to be sent to a function. And so we'll show you what this looks like and what an argument is going to be. A loop, action that repeats a command or a set of commands for a determined set of time over and over again, indefinite. If you've ever had a computer virus typically is an indefinite loop or a never-ending loop. Causes your computer to do something or run all the commands it possibly can without ever stopping or breaking itself. And so that's really what the bulk of a virus is have your computer just repeatedly run itself into the ground doing something. And then we talked a little bit about white space, set of rules in Python that govern indentation and spacing of code. It's very important. Can be a pain at the start, but it really helps us out. And then we do something called snake case. And snake case in Python is very important because we talk about spacing. You can't have a space between the word snake and the word case. So what we do is we teach a concept called snake case where you use an underscore if you want to have something spaced. If I'm going to create a program called Happy Birthday, I would snake case it by putting happy underscore birthday. And so kids really actually kind of like doing snake case because it shows there's supposed to be a space there, but Python won't allow a space. So we put an underscore character in there to get something going. All of the resources that you've got or that we have available to you, we're going to talk about and show you guys where they're at. We use Tinker. I teach 6th and 7th grade, and Tinker is a free coding platform for what we're going to do. Now, Tinker does have some pay to play options on it, There's some great opportunities in Tinker. There's some great things to do, but it can get expensive depending on what your budget is or where you want to go. You can come up with full coding curriculums, but we can do everything that we need to do tonight and everything you want to do in Tinker for free. I've also given you an option of Replit. Be honest with you, Replit is really, I'm always on the fence on if I should use Replit for my 7th graders or stay in Tinker at 6th grade, because Tinker sometimes can feel a little juvenile. It's great, the sweet spot for that 3rd through 5th, 3rd through 6th grade. Some of the middle school kids think it might be a little juvenile or childish, so Replit can come in and take it. If you're going to do any kind of coding at the high school level, I would encourage you to use Replit. Replit really makes it more kind of business oriented. It's not quite as cartoony or kid friendly, doesn't have that stuff. You'll see when we get into Tinker what I'm talking about. Replit is $35 a month per class if you wanted to do it. So it is a paid platform, but you can have as many students as you want, but only one classroom or one team. And so if you wanted to get into Replit, it's just an option. You could certainly code and tinker and use the platform with our high school kids. It just, they might think it's a little juvenile. And then we're going to talk about, I'm going to show you, bounce over to our session resources as soon as we're done with the slide, where everything is at, including this slideshow for you guys to get into it. When we're looking at Python, coding at its core is a math concept. It requires algorithmic and computational things. So when you're teaching math, I'm going to show you tonight how we can use Python to do geometry, how we can use Python to talk about variables and what variables are. We can use it for problem solving, give them something that they need to create a solution for. And we can also use it and demonstrate algorithms. When we look at the language arts side of it, again, programming is a literal language, and it's a great way to teach English language arts, especially spelling. Spelling is going to be your best friend and your worst nightmare, right? When we're putting concepts in, kids have to be able to spell it right. If they're going to use the print function and they spell print with 2 T's, the computer's not going to know what they're talking about. So they got to spell stuff right. Capitalization and punctuation is very important. We'll learn that tonight. We'll just get into our coding syntax. And if you put a period where there shouldn't be a period or a colon, it's important and it matters. The syntax, again, we talked about it, making sure that that's all set. And we can talk about and do some things. I'm going to give you some great tools to do main idea and story. We'll code an adventure story tonight and get you guys started on a choose your own adventure coding program. When we look at science and, you know, how do we get coding or programming into science? We can use it to teach the scientific method. You start with a hypothesis. What do you think this program is going to do? Test your program, run through, reiterate, test it, make changes to it. We can create models. An example I'm going to give you tonight is a scientific, like a planetary weight calculator. So you can take this back and you can create a program that you put in how much you weigh, and it'll say this is how much you weigh on whatever planetary body that you would like to come up with. We can use it for measurement. If we're going to talk about distances when we're coding in Turtle and Python, and I'll get to and show you how we can do measurement with it. And we can create Python programs that collect data for us. You know, if we're going to make a database, I want to type in what's the temperature right now, and it'll collect or get the temperature from me. Social studies concepts, talk about society and the impact of programming on society. Just about everything we do these days is touched by a computer and touched by programming and coding. And so how does coding fit into the society? We can retell history through stories or create codes that simulate past events or past things that happen, create programs that do things with it. We can create code that communicates, artificial intelligence, chatbots, create a program that has a robot that we can ask questions to and it responds and create communication. And we can also maps and directions. Coding at its core is all about the computer does exactly what you tell it to do. So if I tell it to take 2 steps forward in my code, it's going to take 2 steps forward. You can create robots and have robots that, you know, if you code robots with Python, if you have other things that are compatible with Python programming, you can code a robot using directions on how to get around the room and how to drive to where we're supposed to be going to. Some examples of code we're going to get into, and I'm going to get those for you. I just want to show you guys at the very last slide. We're by no means done, but the very last slide has my email address and cell phone number. Call me, email me anytime. So now we're going to transition out. I'm going to get out of this slide, and we are going to jump over to Tinker. Okay, and so what I want you guys to do is hopefully you guys have created and set up a program, set up an account in Tinker. And what we can do is open up your Tinker, and I'm going to share my Tinker screen with you now. And if you log into Tinker with your account that you guys created, what we're going to do tonight is we're going to create some code. Dale's going to be monitoring the chat for me. So if you guys have a question, feel free to drop a question in there. He'll chime in, let me know if we're going too fast, going too slow. We're going to run through some code. Before we get into that though, everything that I am doing is going to be in our data, in our 4C coding. Let me get here. I'm going to share my, where's my other dashboard here? This is the one that I want to share, my 4C materials. All right, let me get this one shared here. I'm going to close that one out. Let's get in here. If we go into the dashboard, this will get in here. All right, let's see here. Where is my, there it is. I'm sharing my screen. All right, so if you come into this, if you go into this, this is our 4C coding material drive that you guys have. If you look at this, and there's a lot in here. So you've got what we've got for our coding presentation we've got here. Then what I tried to do is I gave you two things. So you have a function and variable. So this is a text-based document. So if you need to go or you need to get anything, you can copy and paste this right into Tinker or into a Python program, and this will run the program that you've got. At the bottom, I gave you a link to the Tinker code file so you can see it in action. If you go back, you also see there's one called function and variable, and I took a screenshot that gives you what it looks like with color coding. And we're going to talk about how that color coding is important, and it helps the kids to see where they're at and what they're doing with the coding so they can see what everything that they're doing here, right? So if you get behind or you need something or you want to figure out what we've got, so we've got that for all of the things that we're going to do here today. So you've got examples of the code that's in there for you along with everything that's in here. So what we're going to do is we're going to be in Tinker. And when you log into Tinker, what we want to do is we want to go over to My Projects. Let me give you guys a chance to get over to My Projects. And what we're going to do is we're going to create a new project together. And so this, we're going to go into create a new project, Python, and we're just going to create a blank Python project. And when Python opens up, you're going to see three things that you've got. It always opens up with a basic program that gives you a star, a blue star. So you've got all the code for the blue star, whatever the code is that we're making. What's neat with Tinker is we can use this for free. You don't need to do anything. And so what I've done in my Tinker is I do all my coding in here, but I can also create classes for free that cost nothing. So if I go back to my dashboard, and I'm not going to really go into this tonight because we're getting into the coding piece of it, but what you can do as a teacher is you can go to your classes and you can create as many classes as you want. And in these classes, you can see the projects or code that kids are working on. So I can see the code that my kids are working on to see the things that they're putting together. So this would be a student of mine, Julio, is working on his art project right now and see what he's got here for it. So we can see where they're at with everything in their project. So, and it doesn't cost anything to create the classes, add your students, and create the code. So what we're doing is in our blank Python project that we've got here, this is where we're going to be coding. So the very first thing that you see is this is your output of your screen. So this is what the user is going to see on the back end, on the front end of your code. So you can see both of them. So I can hit stop and play to start my code to see what it is. I can also make the screen larger or smaller and adjust the window to see what happens with my code real time. Okay. In the middle here, this is your code editor. Now, what we're going to get into tonight are just single code files. Now, you can get into advanced coding where you're embedding a Python program inside a Python program or calling another program. We're not going to do that today. This is going to be where we do all of our code. And so the first thing we're going to do is we're going to just delete everything out, and we're just going to hit the backspace to delete it out. So we've got nothing. We're going to start fresh. This is your code editor. Your code editor is always going to give you a single code file called main.py. Now you can rename it. I never do for the kids. We just have them keep the single code file. You would rename them if you're doing multiple code files in the same program. Up at the top is where we're gonna have to name the project. One downfall of Tinker is you can have 36 untitled projects and you'll have to go into each one to see what it is. Or you can go in and hit the pencil to rename it and call what it is. So what we're gonna do is we're gonna call this one input. So what I want you guys to do is just call it input. And what I always have my kids do is give me their name so I can also know what their name is for the code file. So I'm just going to do the underscore snake case. So we're going to do underscore and I'm going to put my name in. So I've got it. So it makes it super easy so that they know what it is. We hit the enter key, it changes the name of our code file for us. It does have an autosave feature, but you can save at any time. And these are always saved cloud-based onto your onto the Tinker site. And as long as a student has a free Tinker account, they can get to their code files. Same thing if you have a teacher account, you can get to it. Now, if you delete your teacher account or the student deletes their student account, they would lose the code files. But as long as they have a code file, they can do it. Tinker is 100% web-based. So part of this is how do we do this with Chrome or Chromebooks? You can do this on a PC. You can do this in a Chromebook. You can do this on, you could even do this coding on an iPad because you're getting into it web-based. So this is all, you can do this really with any device that you've got. If you are fortunate enough to have a computer lab, you can download Python for free and not have to do anything with Tinker and just load the files, code files directly onto your PCs. But if you're like most districts, like myself, we're 100% Chromebook based. We have no computer labs. Students are using Chromebooks. We have to do something that's web-based. We put it into here for the web-based. So the first thing that we're going to do is teach you how to put a comment in. So whenever you start this, if you're going to put a comment in, you're going to do the # shift 3. Comments are gray. And so what I do when I start this out, if I was teaching this to the kids, and we're going to kind of fast and furious and get into some of the coding, is I always give them an example of what the comments are. So comments are gray. Comments are a great way to show what's happening behind the scenes for the coder, but it doesn't show up on the screen. So if I hit play, nothing happens because the comment is something that we're saying, computer, ignore this. This is just for me or for who's using it. So the first thing that kids love to do is get them something to do. So we're going to create a variable right off the bat. So what we're going to do is we're going to create a variable and we're going to call this variable name. And what I try to do with my kids is I teach them every variable you make it lowercase because the computer is literal. Name is going to be what we're going to make. And so what we're going to do here, so name equals, and what we're going to do is put a space after the equal sign. When we do equals is we're going to say name has now become. So I'm saying this variable that I'm creating name is forevermore going to be this. And so what we're going to do is I'm going to type in input. An input is a function. A function is built into Python. Functions are green. And function is going to say, input is saying, there's a computer program that's built into Python that says we're going to get the name of we're going to get something from the keyboard or from the user. So when we do input, we're going to put a parenthesis in here and we're going to put quotes and we're going to put what is your name, a colon behind it and a little bit and a space. And what we're going to do is when we go to the end of our line of code, if we hit play, you're going to see on our screen, what is your name? And I'm going to type my name in. I'm going to type my name in as Burke, and I'm going to hit the enter key. Now, nothing has happened or nothing is showing, but the computer has stored that. Now, we've already got a lot, and I'll tell you guys, this is already, you guys are 2 days into Python, because we'd go way back, what's a variable, what's an input. We're getting you guys into the coding piece of it, so I'm jumping some, getting them going on it. But we're going to give you a couple of things here that we've got. So our function is green. So one of the things that I really like with Python, and the colors might be a little different. If you're doing Python on a PC, the colors could be a little bit different coloring, but in Tinker, if you're going to use Tinker, a function is green. So kids know that if they type a function in and something turns green, they've got a function. And then we're going to put a string is blue. So strings are text characters, and they're put in our quotation marks. So the string is what we are going to type on the screen, or what's going to show up on the screen. So we put, what's your name? So we're going to say that our string is blue. So now what we're going to do is, if we hit the enter key, we're going to go down to our second line. And what I want you guys to do is I want you guys to type in another function. So we're going to type in print, and we're going to put a space, and we're going to print name. And what we're going to do is we're going to hit the play button, and it is going to ask us for, what did I do here? Print name. Oh, I got to put my parentheses on it here. Put my parentheses on here, and we've got it. So I'm going to print my name. So when we print our name, I'm going to get rid of that. So I'm going to put in here, Burke is my name. And when I hit enter, it prints my name. So what we've done here is we've done a function, because we have another function, and this is a very important function. So the function is print. And what print does is print displays output. So print displays output. So print is, don't think of it as we're printing to a printer. We're saying we want to show something on the screen. So if you want something to show up on the screen, you have to do it as a print to display it. Okay, so we're going to print it as a display. We can get really fun with this, and we can have some fun with this. Now, I'm going to show you how we're going to make a mistake here. So if I go back up here, and I'm going to change my variable to capital N name, and I run this, right? And I type my name in again as Burke, I'm going to get nothing happens, because I'm printing a variable called name, and it says here name is not defined on line 3. So at the bottom here, this is our console. The console gives us what our errors are, and what's really good is it tells you where errors are. So my first error that I had is I had a syntax error, because you have to put the parentheses around your function to say what is it that we're going to be printing. But on the second line, it's saying name is not defined. I never created a variable called name lowercase. So a great pitfall that you can avoid, and it took me 1 or 2 classes to really get it and hammer it in my kids and say, every variable you make has to be lowercase, right? And so we create our variable of name lowercase. Now my program is going to work, right? Now, if I do this again and I do my name, it prints my name. Now I could change this and say, I'm going to print name with the capital M in the middle. And as long as I change this to capital M in the middle, I get the same thing, because my code is looking for a variable that is lowercase n-a capital M-E. So you really get into your first English language arts instruction here is punctuation capitalization, right? If I do it as a first name and I put the capital letter at the first name and a lowercase letter, then I'm going to get exactly that. Now, kids can have a lot of fun, and actually I give them some fun with this. I'm going to go back in here, and we're going to show you a couple other things that we've got. Your variables are white, and I forgot to give that at our line up here. So back in my comment here, or I make another line for a comment, start it with the hashtag variables are white. And so starting out, I sometimes give the kids the JPEG picture of the code. I try to never give them the Google Doc of the code, because I don't want them to just copy and paste it. I really want them to type the code in. So we're going to get that our variables are white. Where we get into here, where it's really fun stuff, is getting into our math, and we'll show you some fun stuff. But I'm going to create a variable, and I want you to create a variable of your favorite food, whatever your favorite food is. So I'm going to create a variable pizza, and I'm going to say pizza equals, and I'm going to put the number 5. right? So pizza equals 5. And then I'm going to go taco, right? That's my second favorite food. Taco equals 7, right? And then what I'm going to do is to get them learning about variables, I can go pizza, or I'm going to do here, print. So I'm going to print, and I'm going to print in here pizza plus taco, right? And so I'm going to hit play. It runs through my code. Everything, now remember, everything is sequential. So every time I run my code, it starts back to line 1 and goes through it. So I put my name in. My name is Burke. And now we can have all the kids learn that if they probably didn't know that pizza plus taco equals 12, right? So that's pizza plus taco is going to be 12 for us. How are we doing? Got any questions? Pacing good? Do I need to slow down? I'm trying to see where we're at here. What are we thinking? Everything's good. Dale, we're not hearing anything, so we're good. All right, I'm gonna keep going.
Nothing in the chat so far.
All right, so I'm gonna keep plugging away, assuming everything is good for us, right? So we can do lots of cool stuff. So what we're gonna do is, if you want to keep this or keep your code, you totally can. For sake of this, I'm gonna delete it out. We're gonna start getting into how do we create this stuff and do it. I'm gonna start with the language arts. This is a great language arts. Really, you could do this 4th grade, 5th grade. You can even do it 3rd grade. 3rd grade, it gets a little harder because you talk about the spelling and stuff, but we're going to talk about a Mad Lib. Okay, so I'm just going to delete all this stuff out. For sake of time, I'm going to create a file. I'm not going to rename it, but if you want to start a new Python project so that you've got kind of what you've got, go ahead and create a new Python project. Actually, I will, just to show you guys how to do this. I'm going to go back through, go to my projects, create a new project, Python. And and here's the other thing, guys, is when you get into this, there's some great templates that are already in Tinker that you guys can get into. So if we go into some of these text games, they've got some cool games that are maybe coded a little bit different than what I'm going to show you guys tonight, but you can get into some templates that are already there to get the kids going. But I'm just going to create another blank Python project, and we're going to come up here and we're going to rename this, and we're going to call this Mad Lib. Okay, Mad Lib. And again, I'm going to do my snake case, Mad Lib, and I'm going to put my name in here. So I got Mad Lib. So we've got it. Every project starts with the blue star. So I'm just going to stop it. And we're going to go in here and get this. So now here's where I got this, where we started this. So the first thing that I did is I got a Mad Lib, like I got a paper Mad Lib. So I gave you guys an example of the one that I coded for you here. So if you go in, and I'm going to show you here real fast, this is Mad Lib Vacation. So this is just, I got a book of Mad Libs and I printed out one that we can use, or if you want to use this one, you can use this one. So I printed this Vacation Mad Lib. So it's a vacation is when you take a trip to some place with your family and we do it. So what we're going to do is we're teaching the kids how to create a Mad Lib. So they're going to learn about adjectives and nouns and all of those wonderful things with their Mad Lib. So here's how this works. So the first thing that we're going to do, and what I have them always do whenever they start a program, is I like to have them get it more interactive or make it fun. So I have them get the name of the user, like just like it's something I like to do. I show them like from like Health 9000 and how computers talk to us. So I always have my kids start just for fun, personal preference. We're going to get the name of our user. So we're going to name equals, and we're going to do here inputs, and we're going to ask the question. So I'm going to make my string, and you can have tons of fun with this. We can get it as a pirate. So I'm going to make this a pirate. My computer's now a pirate. So I'm going to be like here, R matey, what? And I don't make it all caps. I'm going to make it R matey, what shall ye be called? That sounds pretty piratey, right? And I'm going to put my question mark at the end. And then I always put a space after it so it cleans up nice. If you don't have a space, when the user is going to put their name in, they're going to put their name in right after the space. So I put the space in to say, okay, I want where you start typing to be one space after my question mark. Okay, so then what we do is we're going to get in pirate voice, we're going to get the name of our user. And then what I'm going to do is I'm going to change real fast. I'm going to throw the kids for a loop. So we're going to print. And what we're printing is the kids freak out and they think, oh my God, the computer's talking to me. We've just programmed it to say a response. And so we're going to print. Now I'm going to switch and I'm going to go into computer voice. So it's going to be a pirate that asks for the name. And then I'm going to do computer voice to say hello to it. So here's how I'm going to do computer voice. I'm going to do my quote to start my string, and I'm going to do beep, boop. And then I'm going to break out here. I'm going to do beep, boop, and I'm going to do hello. And now here's what we do. Put your space in there. Outside of the quotes, what we're going to do is we're going to put a space and we're going to add the plus. So now we're mixing, and there's all the code is in there, and I can point you guys at the end where to start. Start here if you're day one, start here for day two. But now we're mixing, adding a string and a variable. So we're going to print and we're going to add the name. So what this is going to do is it's going to bring the person's name in. Then we're going to hit the plus. We're going to start our string up again. And we're going to put in here, it is nice to meet you, right? That sounds pretty computery. So if I hit play, it starts off in our pirate voice, our matey, what shall ye be called, right? And I'm going to put my name in here, and I'm just going to make my name Ed for right now. And then it says beep boop, hello Ed, it is nice to meet you, right? So we've got it there. Now, here's where those spacing gets important. If you look at my string, and this is really important for our Mad Lib, if I go back and I take this space out of there, and I take this space out of here, and I play it again, I'm going to put Ed as my name. It puts everything in here. Beep, boop, hello, Ed, it is nice to meet you. So when you're doing your strings and you're putting your stuff into quotations, when you put a space in there, it's good. The computer, you're telling the computer, I want you to recreate this exactly. You're going to write beep, boop, hello, and put a space in there. And then we break out of the string and we're saying, okay, now I'm going to add, and I'm going to add this variable in here. This variable of name. Then I'm going to add another string to it, and I got to put my space in there so everything is nice and neat there. Now, if I want to put in a period, I could actually go back, and I'm going to get this out of here, and I'm going to put a period in, and then I'm going to start a new sentence and put a capital I there. Play this again. My name now is Tim. Right, beep boop, hello Tim, it is nice to meet you. Now it types exactly what the user types. You know, Tim is lowercase t. So if I put Tim in capital T, it's going to say hello Tim, capital T, it is nice to meet you. Right, so that is just for fun. That's a great thing to do to get them going here. So here's what the kids are going to do. They're going to go lots of practice creating a variable. So if you've got that Mad Lib sheet or you've got it open, and I've got mine next to me, the first thing that we're going to do is we're going to create all of our variables. So we're going to create a variable. And what I have is I have my kids create the variables blank 1, blank 2, blank 3, blank 4. Now you can either do blank 1 all run together or snake case it blank 1 underscore, whatever preferences. I do it blank 1, get them into the routine of it. And what we're going to do is everything is going to be the same. So we're going to do blank 1 is exactly equal to, we're going to get input from the user, and we're going to get in here, and you can have them stay in their pirate voice or whatever they want. And we're going to say, please give me an adjective, right? And what we are doing is we are saying, I want you to give me whatever that first blank is, right? And so I'm looking at this Mad Lib sheet that I've got here. Let me go back to it and show you guys this. I'm asking for an adjective, then I'm going to ask for another adjective. So this is blank 1 right here is asking for an adjective. Blank 2 asking for an adjective. Blank 3 is a noun. Blank 4 is a noun. So I'm just going to do up to that part. So we go back in here, and I'm going to do now blank 2 equals input. And I'm going to do my quote here, and I'm going to do, please give me an adjective. It's going to be, and I could do another, so they know it's another one, another adjective, right? And I've got my there. Now you can, I don't teach them right away, but for you guys, we're going to make this nice and easy. You can Control C, copy and paste, Control C, come down, Control V, copy and paste. And then I can change this to blank 3, blank 4, and change this to say, give me a noun, right? So, but I want them to get the practice. Please give me a noun. And blank 4 is please give me another noun, right? When I tell them a week or two into coding that they can copy and paste stuff, they're like, why did you not tell us this? Right? So we're going to get all of our blanks. So I'm going to go in here now. Starts out, I, matey, what shall ye be called? My name today is Sam. I'm going to be Sam now. Hello, Sam. It's nice to meet you. Please give me an adjective. So I'm going to put my first adjective in there, pretty. Another adjective is going to be tall. A noun is going to do a beach. And another noun will do the car, right? Now we've got our variables and the variables are stored in there, but we don't have them showing up. What do we need to do? Does anybody know what we're missing, what we need to put in here? This is a quick quiz, putting you on the spot. Any ideas? No? Everybody's nice and quiet. Just stop asking your questions, keep coding.
I'm not sure.
We got to print it. We got to display it. We want to display it on the screen. So remember, to show it on the screen, we have to use our output function to display it. So the way that we're going to do that is we're going to display it. So if I just go here, like I can go here, and I'm just going to show you guys this. You don't have to do this, but I can go here and I can do print blank 1. And then I can come down here and I can do print. And I'm just going to do this and I'm going to do blank 2, right? Just to show you. So I go back to this and I do this. So my name is back to Ed, just to get it going fast. I give my adjective of pretty. I give my adjective of tall. My noun is car. My noun is beach, right? I want to display it. So I'm displaying my variables by printing them out. So that's how I display the output. But what we want to do is go back to what we did for line number 2. And this is where we create our Mad Lib. And so the kids, while they're doing this, they're going to be working on their spelling because they've got the words here. They're also going to be working on their typing skills, right? Because they're going to be typing all of this stuff in. But now what we have to do is we have to get our story. So what I'm going to do is delete this out. And I'm going to start my story with my parentheses. So I'm going to print and I start with my parentheses. So everything goes that we want to print has to be inside our parentheses. So I'm going to start, and now I'm going to start with my string, and I'm going to copy the first part of my Mad Lib, which is the printed part, not the fill in the blank. So a vacation is when you take a trip to some, and then I want to make sure I put that space in there. And then I'm going to come back on the outside of my string, plus, and I'm going to drop in here blank 1, plus, and then I'm going to start my string back up, and my string starts up with space, place. So now if I go look at this, and I'm going to go back here and show you guys this, this is my Mad Lib that we've got here. So my string is this. A vacation is when you take a trip to some. Then what I do is I break the string and put the plus, blank 1 plus, and then I've got place here. So let's test this out. So I've got Ed. There it is. Adjective is pretty. Adjective is tall. My car, my beach. And now we've got our story. A vacation is when you take a trip to some pretty place and you keep it going. So I'm going to go to, just so that you guys get some coding with it, we're going to just go to these first 4 variables. I'm not going to code the whole Mad Lib for you. You guys do have the whole thing, but what I'm going to do is just code this out. So I've got a place with your, now again, make sure you put that, I'm going to forget to put the space just to show you how it looks messed up. Plus, I'm going to bring in my blank 2, plus, start my string up again, and I'm not going to put my space at the front of it. and I'm gonna put family, period, and then usually you go to some place that is near a and then I'm gonna fix this one space, and I'm gonna come out here and I'm gonna do plus blank 3, right? Is that blank 3? There it is, blank 3 plus, start my string up here.
I have a
Or
question.
go ahead. Yep.
While you're inputting that, so what you're taking off of that worksheet, can you copy and paste that, or does it not recognize that? You know, if we wanted to set this up.
You could. I think if you copy from, I don't know if it would from a PDF. If you had it as a Google Doc, you could copy and paste it. Like if you were looking for the younger kids, you could copy and paste it if you gave them the text. I don't think you can't copy and paste it from my PDF that's in there. I don't think. I don't know. Let me try. See if I got it here. Let's try pasting it in here. Oh, it does. You can. You can copy and paste right from the PDF. So you absolutely could copy and paste it right from the PDF. Now you can, you can have the kids create, you can do this at any, you can do this with anything. So up on, and I'm going to do here and then I'm going to add my last one, which is we plus blank 4. And then if I look at that end of that blank 4, I've got that period there. So I'm just going to add in my last string, which is actually going to have the period. Okay, so when we play this, and we've got this, so my name, now my name's Ted. I got multiple personalities here, guys. So Ted, it's nice to meet you. Give me an adjective. So we're going to go tall. We're going to do short, right? Noun, we're going to stick with our beach. We're going to stick with our car. A vacation is when you take a trip to some tall place with your short family. And I notice here, your short family, I don't have the spacing right, so everything is mashed right together. Super easy to fix. I go back in and drop that space next to in my your and before the F for my family, and I can get everything set up. So you can, what's really neat with this is sometimes with these Mad Libs, when you create something like this, you use it once on paper. You can use this again and again and again, and depending on what your grade level is, you can have the kids create their own Mad Libs. You can have them create me a story about Thanksgiving. Whose house do you go to? Give me a relative's name and give me a color, and you're wearing a red shirt. Like you can make it about anything where they have to create a story or they create something, and at some point it's just asking them for, you put on your favorite blank shirt, right? And so the kid is saying, what's your favorite color? And you put on your favorite red shirt, your favorite green shirt, whatever it is that you want to do. You go to the mall and hang out with, what's your best friend's name? Hang out in the mall with Susie. So whatever your variable is, whatever you're asking for is going to be what you're going to put in to your story. Now, you can your kids can make this anything. It's important that your blanks make sense. But I could just as easily, and don't do this, but you absolutely can, but this gets crazy, but I'm going to do this. So you guys just watch this one. I'm going to change to my variables, and I'm going to call it taco. And I'm going to call this one Susie. And then I'm going to call this one, banana, right? Banana. So you can make your variables be anything that you want. But when you do that, you just have to know what it is. So this one, I got to add taco. Then I got to add Susie. Then, a variable can be anything that you want it to be, but it really helps if your variables make sense, right? So I have no idea that taco is my first blank, Susie's my second blank. So it can get a little confusing. But if you really want, if you got kids that's the only way you can get them to do it, you can say, make your variables whatever it is that you want them to be. You can have variables that are SpongeBob and Patrick. And I've had kids that the only way I can get them to do this is if they get to create their variables to be whatever they want. And if they can make it work, they make it work. And that's what we're trying to get to. So, but I like to try to impart on them, if somebody's coming behind or you need me to help you troubleshoot your code, it's impossible for me to troubleshoot your code if I'm trying to find out, okay, what is Susie? Susie's the second noun or the second adjective. But a variable can be anything you want it to be. You just have to make sure that it's the same thing. And remember, taco is very different from capital T taco. And so you get into making sure that they've got the stuff set up the way that it's supposed to be. Questions on the English Language Arts Mad Lib one? All right, I'm gonna jump out. I'm not gonna finish that. We're gonna jump out. We've been going for a while. If you need to take a break, everything is there. I'm gonna keep crunching through this, give you guys a science one. So we're gonna go in for a science one real fast. So I'm gonna drop out. I'm gonna create another one. This one is gonna be science. And we did this one. This one that we've done is going to be a science project. This one's a planet calculator, right? So this is going to be for science or math. We're going to do, this is going to be a science math. So we're going to call this planet weight is what we're going to call this one. And so I'm going to snake case this again, snake casing it, planet weight. And we're going to delete this one out here to get you guys set up, get us our new code. So this one here, what we did for this one, and I gave you guys the link of where I got the stuff. We're going to create something that's called a map, and a map has a location and a value for it, has an argument. So we're going to talk about what those are. So here's what we did. So if you go and look in this 4C coding materials that I gave you guys, and we're going to look at this planetary weight calculator. If you look at the Google Doc, in that Google Doc, I gave you guys a link to where I'm getting my planetary facts from. Okay, so this would be a high school. This would be a high school one looking at it when you're looking at your planetary weight. You could do middle school with this with the updated science standards to get into that. But we're looking at the different gravitational pull of planetary objects is what this, it was what this code would be for. So I opened up, and this is the planetary fact sheet. So all of my data is coming from here. So this is going to be what our gravity is. So our gravity is right here. So this is our gravitational pull compared to the Earth, right? So this is what we're coming up with. So what we're going to do is we took that data and we're going to put it into our code here. So the first thing that we're going to do is we're going to create a map. Okay, and there is in the code that I've given you guys, and we'll go back to day 2, and as we get close to the end, I'll show you, start here, go to this one, so you can teach them about maps and lists and give them that background knowledge, or you can just jump right in and say, I'm going to teach you guys how to make a map, which is what we're doing. So we're creating a map called bodies. This is going to be all of our planetary bodies. And what we're going to do is it's going to equal these values that we're creating. So what we're going to do is we are going to use the curly bracket, and in the curly bracket, we're going to create a planet, or we're going to do our bodies. So our first one is going to be Mercury. So we're going to put Mercury in here. And then outside of Mercury, outside of the quotes, we're going to hit colon, and we're going to say Mercury, it gets the value of 0.378. Okay, so Mercury gets a value of 0.378. What I'm pulling that from, so that you guys have got this, and we're going to drop these in, is this is going to be our gravity. Right here's our gravity, 0.378. Earth is 1. Everything is compared to Earth at 1. So this line right here is where I'm taking this data. Now, if you really want to have some fun, is you could have the kids come up with what's the ratio of gravity from compared to Earth to create the planetary calculator. You can have them go first find all of these and not necessarily give them the fact sheet from NASA if you want to do that. So we're going to go in, and for sake of it, we're going to create it. And so we're going to put a comma. We're going to add our second map, and we're going to say Venus. And we're going to add Venus, and for Venus is 0.907. And then we're going to add What I'm going to do is I'm going to copy this in. So I'm going to go back to our copying in just to get you guys going here. So I'm going to copy this in from my planetary weight calculator. So I'm going to copy this stuff in so that we've got this, just to save us a little time to get us going here. So I'm going to copy that, come back in here, and I'm just going to drop this right in. Control V, I've dropped it in. So here's what we've got. We took all that data, and what we have created is a map, a tuple. And so what this does is this is saying, we're mapping it out, saying if I put in the value of Mercury, I'm going to use this value here. If I type in the value of Venus, I'm going to use this value here. If the user types in Earth, I put in this value here, right? So what we're saying is whatever, we're going to compare it to whatever planet we want. So what we're going to do is we're going to get the weight from the user. So we're going to create a variable, and the variable is going to be weight. And what we're going to do here is weight, we're saying is exactly equal to. When we get into Python and coding, if we're doing we're saying is equal to this. So we're saying weight is now, we're going to get a variable number. So we're going to get an integer. So int means we're going to get an integer, and we're going to put in here raw input. So we're going to get the raw value from the user, parentheses, and what we're going to get is enter your weight. Enter your weight in pounds, right? And so we've got their weight in pounds. And so this is going to get the variable from the user. So when we get their weight in pounds, right here, you guys are going to get 242, right? So we get the weight in pounds. So now what we're going to do with that is we're going to go to our next line. So this is going to, I'm going to put a comment here just so you get weight of the user. So when we come down here, what we're going to do, this is an important one for us for this one, because here's what we did. Remember, we talked about how case is important. This is a very important line of code that I put into this program to help you guys out. So when I put Mercury in here, I put Mercury in lowercase. If I put this in and I put Mercury with a capital M, the user playing my game or using my calculator would have to put in a capital M. So this line of code will save you all kinds of headache. And what we are going to do is we're going to first create what body do we want them to do. So we're going to create the body, and we're going to say input. And what we're going to get for them is, and we're going to give them let's see, I put my quotes in here. What celestial body do you want to be weighed on? Right? And so that's what we're going to do. So we're going to do that. Put a question mark. We're getting a value. We're getting, where do they want to be measured their weight on? Right? And so now what we're going to do here is they're going to pick their planet or the moon. So they're going to pick their object. So this is going to be pick celestial object. Okay. So now what we're going to do here is, this is where it gets very important. We're going to do body equals, and this is something that will save you so much time. And what we're going to do is body dot lower, and you're going to do open and close parentheses. What this does is this is forcing the variable, no matter what they type. I can type it in all caps. We're saying that we're going to make body and force everything into lowercase. So forces to lowercase, right? To make sure that everything is lowercase, regardless of how I type it in. If I type it in all caps, like I'm yelling my planet, this program is going to force it to change to lowercase. That's important because right here where I've got Saturn, Saturn is very different from capital S Saturn, according to our computer. Okay, so then what we're going to do is we are going to create our math problems. We're tying our math in here. So what we're going to do, and I called it, made it nice and neat here. I called it celestial, and I didn't do, I can do the snake case here, celestial weight, or sometimes you can do celestial weight with a capital letter, just so you've got it, equals. And what we're going to do is we're going to say, okay, bodies. So we're going to pull from our bodies list. So we're saying, I'm going to go to this list and I'm going to map it So bracket, not curly bracket, regular brackets, regular bracket. I'm going to map it to the body variable, whatever my user put in. So what I'm saying is this variable that I get from the user here is going to go into here, and it's going to pull this number. So there's a whole lot going on here, but we're going to pull that number from here. And I'm going to multiply that. Multiplication is the asterisk symbol. And I'm going to multiply that by weight, right? So that's going to be what my weight is. And then, so this is I'm just going to make a quick note here. This is our formula to figure weight. And then what do I need to do? Well, and do you remember now? It's there, but I can't see it yet. What do I got to do? Anybody remember? Most importantly, print. I got to print it. There it is. That's what I'm talking about. I got to print it. So I'm going to print now, and I'm printing this variable I created called celestial weight. So I'm going to print celestial weight, right? And now I hit play again. I weigh 242 pounds. I want to be weighed on Venus. So I'm going to type in Venus, and there it is. Now I could take this a step further. I just printed it out, but I could get and put in I could print in here. You would weigh, right? Then I'm going to put my parentheses here, plus celestial weight, and I would do here plus, and I would put space, pounds on, and then put my plus in here, and I'm going to put body, right? And then put my plus, and put my single quote in here, and put my period. So now I've got this. So I enter my weight in pounds, 242. This time I'm going to go Uranus. So I got Uranus. There it is. Oh, what did I do? Oh, string and float. What did I do here? Oh, I got to do my celestial weight. Oh, we got to get that too. I got to change to print my celestial weight is going to be my percent value. That's going to be too much for this one. Let's take that one out. Let's do this. You would weigh, do it like this. This is going to be the easiest way. It's going to get a little advanced if I do it that way. So I'm going to do this, put this to here, and then I'm going to go on to a next line. It'll come together here. Print. Now this is gonna. So what we're doing is we're adding in a print feature, and I can show you guys how to do this later. For the sake of time, we're just gonna kind of get around it. But we're gonna print the celestial weight, and then I'm going to print. Let me make sure I get this right. You would weigh. Put my space in there. Then I do a new print line. Pounds on. There it is. Now when we do this, so what you're getting into is you cannot consonate a string and a float because your float is a number on there. Oh, what did I get on line 7? Oh, I forgot to put my parentheses here. So there's my parentheses and my parentheses. Now we've got it working here. So enter my weight, 242. Celestial body, I said I wanted to be Uranus. You would weigh 250.138 pounds on Uranus. Right now, there is a way, and I can get into it and take us. We'd run way past our time tonight of what we're looking at to get into that. But this is a great way to get in and get our to get the science coding. Questions on the science and math one? Get that one in. I want to keep giving you guys some more. What are we doing? We're doing good. All right, we're gonna go into you can even do a social studies. So this will be a social studies one that we're gonna do. Say you're learning about your 7th grade, 6th grade, whatever grade it is. With 6th grade science, we learn about the Ojibwe, right? And you're gonna create a story or retell a story about the Ojibwe. This I got and came up with and kind of pieced it together from different things from choose your own adventure books. When I was growing up, I used to love choose your own adventure books, you know, where if you want to go into the cave, turn to page 142. If you want to go to the lake, turn to page 37. What we're going to do is create a choose your own adventure book. And this, kids love this. And you can do this English language arts if they have to create a story and you're working on main idea, plot development, character, setting, you know, because you're going to create the setting. Think of this as what you guys are creating with this choose your own adventure is essentially Oregon Trail. Like you could literally recreate Oregon Trail through Python fairly easily if you wanted to. And I'm going to show you guys kind of how to do that. So we're going to create a new program here, and this is going to be our social studies vein. Now, where I would go with this is whatever topic you're learning about, maybe it's you're learning about the Ojibwe Indians and what life was like for the Ojibways and what a day in the life was. You can create an adventure story about, hey, you're an Ojibwe. What is it that you're going to do first, right? And how are you going to do this? So what we're going to do is create our Python program. Again, start with our blank project. It doesn't matter if you create it as a blank project or a text project. They all start the same and tinker with the star. I wish they would just give you a true blank project. So we're going to get this one. And what we're going to do here is we're going to call this adventure. And I'm going to snake case it with my name. So this is going to be adventure Burke. Okay, so that's going to be my name for adventure Burke. All right, so here's what we've got. So we have got this. We are going to go. Dale, I'm trying to remember, what time was I done at? I know I'm into the second session already, but when do I need to be done?
7:20.
I got time. We're doing great. We're doing great, guys. Okay, so here's where this one is that I'm going to give you guys when we're getting into this one. And this, I got to tell you guys, is my favorite one. And this is I call it a choose your own adventure. So this is going to be your own adventure that you're trying to come up with. Okay. Now, again, hopefully your kids have done some stuff with variables and they can get some things in here. I love doing the variables. Variables are a great way to get them going. So I always start with name and give me your name, right? So we're going to start with this off again in your best voice. I think I'm going to stick with my pirate voice, right? And I'm going to go here. Matey, there we go. What be ye name? That sounds pretty piratey, right? So we've got it. And then we can even take it a step further, and we can get, if we really want to get it to have some fun, is I have my kids come up with one article of clothing or shirt or something like that. So it just kind of makes it so it's a personal touch to the game. Because sometimes these games, you can really make them interactive. So we're going to create one here called shirt. And what I want you to do is you're going to create another shirt. We're going to create an input for it. And this is going to make sense for you guys here in a second. And we're going to put in here put my quotes on here. What color shirt do you have on? Okay, so those are going to be, so we're going to get two variables from our player. Okay, so we can always test our code. We hit play to run our lines. What is your name? My name's Ted. My shirt, right? I had to, guys, you're not going to believe this. I actually had to look down. It's been that kind of a day. I forgot what color shirt I was wearing when I left the house today. So if you didn't see that, I just looked at my clothes to see what color shirt I had. We don't see anything. They're stored, but we're not printing them. So we haven't seen them yet. So now what we're going to do is we're going to create our story. Now the possibilities are endless. You can have the kids retell a story about Lewis and Clark. You can have them create their own story about what it would be like to have a life or to be there. Okay, so what we are going to do in this one is we're going to start to create the chapters or the sections of our story. So what we're going to do is we're going to put a comment in here, and what we have to do is we're going to create, we need to define the functions or chapters of our story, right? Or these, not even really a chapter, it's going to be kind of our choice points of what we're going to do. So the way that we're going to do is we're going to create our intro. Okay. So what we're going to do is we're going to hit, and we're going to use what's called DEF. DEF is going to be the command to define. So we're going to define a function, and the function that we're going to define, we're going to call it display, and we have to do the state case on this. We're going to do our intro. So this is going to be our intro. So this is going to be what starts our story out. And when you define your function, you have to use the open and close parentheses to show that that's you can pass arguments to it. We're not going to pass an argument into it just yet. And we're going to put a colon. So that's going to say we're going to create our display intro function. Okay. And this is going to be, what we're doing here is create a function to our story. Now, this is where sequence and spacing and all of those things become very important. When I hit the enter key, you're going to notice that I've already indented over one space. And that's what's saying is we're in the second section of our Python coding. So we defined our function, it's left aligned, but now what's going to run inside our function has to be inside our function that we've created. So what we're going to do in here is we're going to print our intro of what we're going to say. So we're going to print our intro, and we're going to say hello, and I'm going to put my space in here, and this is where I bring in the fun. I'm going to add the name of the person, hello name, and then I'm going to add in here welcome. And this is going to be, we're going to make this a scary story. To your worst nightmare. Oh, this is sounding bad, right? This is terrible. Oh, and I'm going to put a couple exclamation points in there. Make sure I spell welcome right. That doesn't do me any good to, it's already a nightmare when you can't get it. So now we've got it, and we're printing our welcome message, right? So this is going to be the first message for us. Now I can print another line after it. And so I'm going to print another line after it here. And it's just going to be a string kind of telling or building up the story. I estimate your chance of survival to be, and I'm going to, for added effects, there it is. Look at this. This is scary. You guys are already getting scared just thinking about it. So I can test it out. I hit play here, and I get my name. And so my name is Ed. What color shirt do I have on? I haven't gotten to my shirt yet. And oh, I know what I did wrong. We have to display our intro first. So what we are going to do is we're going to come down here, and what we are going to do is we have to display our intro. So we created that function. So stuff is not printing out because we're going to skip a line, go down to line 9. Make sure you go back to the left of line. And what we're going to do is we're going to say, I want to do display intro. Okay. So this is saying I am going to play the first part of my story. So this is going to be our display intro. So now when I play again, my name is Ed. My shirt is red. Hello, Ed. Welcome to your worst nightmare. I estimate your chances of survival to be 0. What we've done here is we created a function, and now we've called it. We're saying, okay, I want you to run this function. So this is our intro function. So what we're going to do, and this is where the sequence comes into importance of play. So we have to create all of the chapters or sections of our story and organization to get everything at the top. So we're going to come back up above our display intro. I'm going to put a couple of lines in here, like just blank lines. And now we're going to create our next functions. Now, when you create your functions, it doesn't matter what order you put them in, as long as you call them in the right order. right? As long as you have them all defined at the top before I start my story, it really doesn't matter what order I put them in. So if I forgot a chapter, or I wanted to add another branch, I can add them in there. And so to show you that, I'm going to add them in. I'm going to add them in order first to start them off. And so what we're going to do is we're going to create our first chapter. So we're going to define a function, and I'm just going to call this chapter snake case 1, chapter 1. Open and close parentheses, put our colon after it, going to hit the enter key, and it's already got me going over 1. Okay, so now what we're going to do is I'm going to create my chapter 1. And so what I've got for my chapter 1 is going to be where is it that I'm going to go with this. So what I've got first is I am going to come into my intro where I wrote down the start of my story here. So welcome your worst nightmare. There it is. There it is. And so now what I've got. Okay, so I'm going to start in here. So I'm going to do print, and I'm going to print my story. So I got here, you wake up in your favorite, right? Now this is where I'm bringing in. So I'm going to add in that color of the shirt. So I have added in, and I'm going to add in shirt and add this in here. Put my code in here, shirt. Okay, so I am waking into my favorite shirt. So now I've got my favorite shirt, and I'm going to say that we're going to give us right around here. So I'm going to print my second line here. So we're going to say here, you are at school and see that nobody is around, right? So we're just setting up our story. And then I'm going to print my next line here. And so what I'm going to do is we're going to say here, to your, let's see here. I'm going to put, and we're going to start them off right off the bat. You hear, oh, I don't need this, the space at the beginning there. You hear a loud sound outside the door. Okay. So now we're setting up our scary story. So now what we're going to do is we're going to create a choice. And so here's how we're going to do this. So this is, and you can make your choice with things. Now we're going to create a variable, and this variable is going to be our choice point. So we're going to create this variable, and we're going to call this choice, and we're going to equal, and this choice is going to be, we're going to get input from the user. So what we're going to do here for our choice is we're going to say, we're going to get an integer. So when you do int, that says we're going to get an integer variable from the user. So we're going to get a variable from our player. So we're going to get a number. So we're going to get int input. So we're going to get input from the user. That's going to be a number in nature. And so what we are going to do is put our parentheses in here. What do we want to say? And we're going to say, do you one? So we're gonna say what we're gonna do. Do you one? And we're gonna put in here investigate. Okay. Or we're gonna choose. Let's see here. Input. Do you want to investigate the sound? Oh, okay. Let's do this. We're going to put it into here like this. So we're going to put it, do you one, investigate the sound, or two, ignore. Okay. And so then we've got it here. So we've got our choice there. So that's going to be where our choice is. Okay, so now what we're going to do is we're going to say what happens to them. So we're getting an input from them and we're giving them their choice. Do you want to investigate the sound or to ignore it? And so what we're going to put in here is we're going to put in what's known as a if-else statement, which is we're going to try to see what happens. So we're going to do if choice. Now what we're doing here is choice. You have to do two equal signs. So what we're saying is it's exactly equal to. So if they push any key that does not match this key, it will not do it. So if we do choice 1, we put our colon. So this is what we're saying here is they chose 1. They chose 1. Now we're going to say if the choice is exactly equal to 1, you notice now we're indented again because we've embedded in. So our function is defined, everything's indented as part of the function. Now we've created an if branch that's indented, and we're going to put it in here. So our if choice, we're going to print what happens. Print, you investigate and see a fuzzy bunny, right? So you see a cute bunny, see a fuzzy bunny, and see a fuzzy bunny. All right, so that's going to be our first choice. Now what we're going to do is we're going to go back to this, and what we are going to do is we're going to go back to our indent again, get back out of this, and we're going to do if choice is exactly equal to 3, we're going to print you should have checked it out. It was a zombie that ate you. Right, there it is. So they're done. That's the end of the story. Okay, so we're going to print our choices of it. So now to get this, if we're trying to get their choices, oh, I did 3. I didn't want to do 3. I meant to make it 2. Choice is 2. So we're gonna do what happens for choice 2. So if I go in, what we need to do now, if I hit play, what you're gonna see is I put my name in as Ed, I put my shirt as red, and it just gives me my intro. What I have to do is say where I want to go next. So now there's 2 places I can do it. What I like to do is have it go in, and I can call the next function here. So what I can do here is do chapter 1 and do my open and close parentheses, and it will go right into chapter 1. Or one way that I'm going to show you to do this is we can put this at the end of our function to say we're going to go to this next part of the function. So I'm going to go right into here, and I'm going to do chapter 1, open and close. So now what's going to happen is this is going to take us to chapter 1. So when I hit play, my name is Ed, my shirt is red, and it gives me, hello, Ed, welcome to your worst nightmare. I estimate your chance of survival is 0. You wake up in your favorite red shirt. Oh, I forgot a space there. You're at school, see that nobody's around. You hear a loud sound outside the door. Do you want to investigate the sound or to ignore it? If I choose 1, gives me my choice. You investigate and see a fuzzy bunny. Play the story again. I'm Ed. My shirt's red. I'm going to ignore it. 2, you should have checked it out. It was a zombie that ate you, right? And I got some spelling here, so I should have checked it out. Put my shirt. Where's my shirt? We're going to get it. So here is what we've got here. So now we've got our 2. So I've got my chapter 1, and what you can see here is in my display intro, I run the display intro. So it does this line first, then it does this line, then it goes right into chapter 1. Then I'm running into chapter 1 here. Now what I can do is say, if I do this fuzzy bunny one, what I'm going to do is go back, and inside this fuzzy bunny one, what I'm going to do is, because I'm still in this if, so I'm going to be aligned up with it. I want to say, okay, I am going to go, this is going to take us to chapter 3. So I'm getting a little ahead of myself because I'm putting this into chapter 3. So now what I'm going to do is go down here, and I got to create what's chapter 3. So I'm going to go back to the beginning here. Def and I'm going to call this chapter 3, right? And so now I'm in chapter 3, do my open and close parentheses, and I'm going to print chapter 3. Print, right? You walk down the hallway and see Mr. Egner, right? So now we're going to give them another choice point. So we're going to give another choice point. Choice. So we're going to make another choice, and we're going to say choice equals, and we're going to get another, we're going to do the same as their integer. Now we can also do, you don't have to do a choice as integer. We can do choice, and we'll do input, and we're going to say we're going to get input from them. We're going to do choice input, and we're going to say input. Now here's where it gets, I like doing the numbers because you would have to do, remember we went and did that body to put everything in lowercase. So you could also get an input, right? And so, and we could say here, do you say, I'm going to change this up. You walk down the hallway and see Mr. Egner. We're going to add another sentence in here. Print, and we're going to do here, you are late for class, right? Okay, so we're going to put in here, so you're late for class. So we've set it up. Do you run left or right? Now there's two ways you can do this. If I do this, you run left or right. I could put in here and give them this, and I could put in here case sensitive, so the kids know, right, what they want to do, so, or what they want to do, or I can give them left or right. Or if you're going to do just the input, what I can do here, change this to a question mark, not a colon. I can go down here and I can say choice, and I'm going to go back to, if you remember back from our science one, we can put in our lowercase. So we're going to do choice equals choice dot lower, right? So we're going to make it choice dot lower parentheses. So that's going to force choice to be lower. So now we've added a couple extra lines, but now what we're going to do here is going to do if choice is exactly equal to left, right? So we got our left. Then what we're going to do is we're going to say what happens if they go left. Choice is exactly equal to left. Then we're going to print. Let's see, he catches you. He catches you, right? And we'll go back here and do if choice is exactly equal to, and we'll say we're gonna, because we're getting our string here right. I'm gonna put a colon here. We're gonna say print you, oh, put my quotes in here, you get away, right? And so now what we've got here, so here's how this is gonna work. We start with our intro. We run in our display intro, so the code runs through our intro. So the very first thing happens, it gets a name. So we get the name of the player, get the favorite color shirt of the player. Then all of this is behind the scenes. We're creating our chapters. Our program doesn't start until we say what function are we going to run first. So we ran our intro, right? And you can even call it define intro. I did display intro, but you can even define intro. I could start my story right at chapter 1 and skip the hello, I estimate your chances 5-0. I could start it at chapter 1 if I wanted to. Whatever I do, I can start it here. So once I start it, it's going to run, display intro runs first. Now, when you look at my display intro, there is no other choice for people to make, but they runs right into chapter 2. Prints this line, runs chapter 1 next. So now I'm going to go to chapter 1. Now, just for fun, just to show you guys, I'm going to cut this out. So I'm going to Control X this, and I'm going to put this still above everything, but I'm going to put it down here. So my chapter 1 is above, below chapter 3. So it doesn't matter, as long as everything is defined, you're okay. So it's going to run chapter 1. So now it goes to chapter 1, prints these lines, and I have a choice to make. If I choose wisely, I continue on in the story. If I choose poorly, that's it for me. So it's going to go to chapter 3. Get into chapter 3. If choice, prints and catches you, prints and catches you. Wherever you want to make it, I would just come in here and I would put in chapter 4, right? And I could make it chapter 4, and that would be where I would put my chapter 4. Now, because we haven't created chapter 4, I'm going to comment this line out so that they can't, so it won't run. We're going to hit play. My name is Ed. My shirt is red, right? I'm going to, what did I do? I got to investigate it to go on. Yes, I got to investigate it to go on. I'm going to go left. He catches you, right? And so I can keep going through it. So the way that you can use this for your social studies is tell the kids they got to have 4 branches. You got to have at least 4 different branches. And really, because there's no graphics, you got to set it up. You got to put in here, what did the Ojibwe Indians wear? You're wearing your best headdress, and you've got your leather arrow quiver, and you've got all, so they can put in elements of detail for the setting, and what does your teepee look like, and where are you going? And I mean, you can really get into and do some crazy things with it. We've got about 7 minutes left. I kind of wanted to open it for questions, see if you guys had anything. There's tons more. Oh, I got to give you one more. If you were going to do this, if you're going to do this at home, what you would want to do is, if you would start off, and I would start off with the input strings and tuples. So this would be the first one that you start off with, trying to get them going. This gets you set up with how do you get inputs, how do you create a list, how do you create a different string. Then from there, you could go into this functions and variables, and this will get them set up, creating functions and what a math integers look like. How do you put functions and variables together? How do you make those go?
Can you share your screen?
Oh, I'm sorry. Let me share that again. I stopped sharing, and there it goes. Okay, back at it. So I would start, if you're looking at this stuff, start with input strings and tuples. This is where you would want to start. Start off, they love to get right out of the gate, getting their name and how do you print it. Talks about what color everything is, variables, give them the comments, what color functions are, what color strings are. After you did that one, I would then go into functions and variables. This gives them a little bit, talks about what math operators are, what does the multiplication symbol do, division symbol, add, subtract, how do you get into and do those things, right? Then when we get into that, really kind of where you want to go. If you were going to get into, like with the younger kids, I would maybe start with the turtle next. We didn't even really get into the turtle, kind of ran short of time. Turtle's that was how you created the star. Lots of geometry and things you can do, have the turtles move. You have them move forward, have them move backward, make a right turn, left turn, talking about angles, right? This is also really cool because you can create shapes. If you're talking about shapes, you can have your kids create triangles, squares, circles, diamonds, whatever shape you've got, you can have them code it to create the shape that you're looking for them to create. Other examples of code that I gave you guys, gave you the Mad Lib, the vacation. Here's a great one, talking about questions. It's a magic 8-ball. This one's a really cool one where they have to, you remember the old 8 balls that you shake, and it's, in my case, the one I ask every day is, will my hair grow back? And they have to come up with 10 responses. Outlook doesn't look good, never happened, maybe tomorrow, ask me again. So this is where you create a random kind of ask a question. Is Mr. Egner my favorite teacher? And you could take a yes, no question and give them lots of cool answers. That's a fun one to do. Guess the number. This is a great math one. probability, how quickly can I get something? So we did this, created a set of numbers or number lists, and they have to guess the numbers. They have so many chances to get it, right? You can use math. The bigger the number, what's the chance that they're going to get it? You know, if you get a 2-digit number, they got a pretty high chance of getting it. If you get a 1-digit number and you give them 10 guesses, they're for sure going to get it. So you can talk about probability and outcomes. You can create a longer number to get different things in there. We did the planetary weight. You can do this really with anything, whatever calculator you want them to make. For math, you can have them create a calculator and put their formulas in, and you can put in the Pythagorean theorem, and where they put in what is A, what is B, what is C, and it creates the calculator. The calculator will do all of the coding for them of the things that they've got. So that will give them lots and lots of examples for code. Questions, anything that I can answer for you? Anything else that I'm missing, or what do I got to do? I got to take the period out of the Google Drive. Did I mess something up?
I had a question,
Okay.
and you probably covered this. I don't know if I just lost it. I think you might have covered it in the beginning. So when you create this, you know, like the code for them to answer, and you're doing it within Tinker, where does that share to? Say they wanted to send someone to go ahead and fill out, you know, and answer those questions. Does it save as a Google Doc?
No, so it's actually is a Tinker code file. So what they would have to do is in Tinker, and I can share that. Let me share my screen again for you. So if I share again, and I go back into the Tinker, what I can do is up at the top here in my Tinker code file, I have these options where I can share my code file, and it is right here. So this is gonna be, no, where is it? Where is my, let me save it. There, oh, up at the top here. I got my, I gotta move my Zoom window. Right here at the top, it'll give you my share. So this is where they can share. This is a link to their code file that they could do. They could email this. Now this won't work depending on how you got it. So don't do the email, because if you're like our district and using younger kids, our external email is blocked, and you'd have to have Tinker whitelisted. Your tech department might not like that. But you can also, if you just embed, this is your code. So if I take this code, they can copy and paste that code and give that to somebody else. They can put it, you can take that and put that into a Google Doc or a Google Classroom. And that's where that's what you would get if you're going to embed that in, if you wanted to take that. So that's where you would take the share. I don't use the email because we have external emails are blocked, so our kids can't get them. So you don't want to do that anyhow. But that would be, you could embed the code and get it that way. As far as for the kids, like for you, if you create a class and add the kids to your class, you can go in and see all of their code. Any project that they're working on, you can see the code that the kids are working on to get them going. And there actually is in Python, and every year they do have, there is a set of lessons, 10 lessons that are free to get you started or wet your whistle with the Python, called Python 101. So you could actually go in this Programming 300 and give them some Python lessons. So this Intro to Python will give them a kind of a free getting into coding that you could do for Python, that even goes a little bit more in depth into how does the coding work for it.
And then with that access code, so say I wanted, or like my daughter, if she's in Mr. C's class and does this in his class, she comes home. Could she send me that link and I could go into Tinker without an account to do that? Or does everybody who uses that link need to create a free account?
No, nobody, you don't need to. It creates a free link, basically just takes it right to the code. So you don't need a Tinker code. So if you weren't logged into Tinker, at the bottom of each of those Google Docs that I gave you is my embedded snippet. So you do not have to be logged in. If you're logged out of Tinker, you can click on that link and it'll open up. All it opens up is basically a white space that you see that window on the right. It opens up a white space and runs that code.
Perfect.
So, yeah, so you could send that or share that with anybody. Now, what you would want to do is, they could, depending on how your email is, They could either share it through Google Classroom or give it to you and then you email it to mom and dad or something like that. Because, you know, with some of ours are blocked that our kids don't even have email accounts, so they can't email it home to mom and dad. Depending on how your district is set up, you just have to follow those emails. Mr. Triton, do I need to see Triton? Is there something I need to do for my resources, or are we good?
No, the link you put into the chat has a
Yep.
period at the end of it.
I got you. So take that period out and then it'll
Yep.
go. All right. I want to make
And it will
sure that
go.
everybody can get into that.
Yeah. That was the issue I was having. I'm like, that didn't make sense, and so I took out the period, and then it flew right into it. Otherwise, I got a 404
Perfect.
message.
Perfect. All right. Any other questions? Len, did you have another question? I see your hand still up, or did we just forget?
No, I just didn't put it down.
That's
yet.
okay. No.
Nope, you answered the questions I had on it. Thank you very much.
Perfect. Well, guys, I'm here. You've got my phone number. Really, I do love this. Like, if you've got something or you got an idea or how this is what I want to do, I'd be happy to try to put some code together, give you guys some other ideas, talk with your team, do something on the side. You know, that's my cell phone. Share it with anybody. Share the resource files with them. I love coding. I love doing the coding. I just want to make sure we can get it out there and get it going. I'm happy to help out anytime, any place. We'll get it going.